Okay, dear student, let's see what is there in this question. A single pulse travels towards the free end of a hanging vertical string. The pulse is reflected. What is the shape of the reflected pulse? So what is actually happening here? We can see this is the rigid support, and from this rigid support the pulse is moving downwards. So this is going downwards, and this is the free end, and at this free end it is getting reflected. So you have to find like how is that going to be reflected. So what are the principles that we are using when we are doing questions for the reflection of wave? This topic is from the topic C3, so you can go into details if you want to refer to that. Okay, so what is happening here is, let's say there is this rigid support here, and there is this string, and there is a pulse which is moving towards right hand side direction. Of course it is going to cover this distance. It is moving at certain velocity. It will hit the rigid support and it will be getting reflected back. There is no doubt about it. But when it is getting reflected from the rigid surface, so what happens is it moves like this. So one thing that you have to note, that you can note here, is that definitely the motion of energy transfer is completely converted. It is completely opposite. It was going towards right, now it is definitely going towards left. But one more thing, it is getting inverted. Now it is getting inverted. Why? Because it is hitting a rigid support. It is hitting a rigid support, and that is why it is getting inverted. Now in the layman term we can say that it is getting inverted, but from the physics point of view we call it a phase shift of pi. So we will say that yes, it is getting reflected now, but there is a phase shift of pi which has taken place, and so the wave is now inverted and going back. What happens if this is a free end? Now what do you mean by free end? Free end is having a ring, and this is kind of a rod or something, or a pole we can say, and so this ring here is not restricted. It can go up and down, it can move up and down like this, so it can go do anything there. Let's say the wave is coming towards the right hand side direction now. Now what happens? Of course there is no way in which it can keep on moving in the same direction, because as soon as it hits this end it has to be reflected. But because it is the free end, the inversion does not happen. The phase shift is not taking place. It means that it will be reflected just like this. So only the direction of the velocity will change, but the phase change will not take place. So these are usual principles that we take care for. Now in this question you are in fact using a third principle. Now what is that? Now the pulse is not looking symmetrical. So the pulse is coming here and it is getting reflected from free end. So one thing is pretty clear, that because it is getting reflected from free end, it is not getting inverted. So the wave is definitely going to remain this side but not on this side. So this is wrong. It is not going this side. So out of this two options, let's see, like A, B and C, D. So these are the options. So in these two cases the pulse is now inverted, and so definitely C is wrong and D is wrong. There is nothing that we can do about it. Now moving about A and B. Now what happens here? So you have to consider this. When the pulse is moving like this end is taken to be the front end, and this can be taken as the trailing end. So when it is going the other way around, even then the front will be front and the trailing end will be the trailing end, and that is the only case in the option B. Like for example, this is still the front and this is still the trailing line. So B is the correct option for this question and A is still wrong. So this is how we do this question. I believe this question is clear. This is a very important question. IB has asked so many these kind of questions also earlier, so you can remember this. Okay students, thanks for watching the video. Please keep watching the other videos in the line. All the best. Bye.